Hello students, this is a video on the topic tests that Bodhee Prep has made available for you. The idea of these topic tests is that once you have done the concepts of a topic, you can take these tests to see how well you're able to apply those concepts in an exam. Uh, Once you take the test, you can look at this video. So this video will help you analyze the test as to how the questions could have been attempted, what would have been a good attempt, the kind of time that you need to put in for the test. And we have more than 200 such topic tests available on the Bodhee Prep Android app. So the link for this app is in the description below. Feel free to download the app and make use of these tests. This video is about the topic number system, subtopic divisibility rules, and this is the first test on the subtopic in the app. Test number one. If you look at the overall test, it was a moderate level of difficulty test, about 6 questions. Net correct would ensure a 90 to 95 percentile. Ideal time to go through the questions would be about 21 to 24 minutes because clearly there are questions where some cases are being formed. Let us go through the questions once and then let's see which questions should have been attempted to minimize the time and ensure that we get the 6 questions correct. If you look at the questions one by one, question number one says, all natural numbers a natural number consists of only zeros and ones. If the number is divided by 375, what is the least possible number of zeros and ones in the number? Now, 375 is nothing but 3 into 125. If we look at the zeros and ones, if we have to find a number which consists of only zeros and ones and is divisible by 3, the smallest such number will be 111, which is 3 into 37. 111, 111, 10, 100. None of them are divisible by 3. The first number is 37 into 3, which is 111. Also, if we have to form a number which uses only ones and zeros, divisible by 125. 125 is 5 into 5 into 5. This will divide 10 into 10 into 10. So if we look at the number, if we have a number which is 111, 000, this comprises of only ones and zeros. 111 will be divisible by 3 and 1000 will be divisible by 125. So 111000 will be divisible by 375. What is the minimum number of zeros and ones? It can have 3 zeros and 3 ones, and therefore none of these becomes the answer. Overall, an easy question. We just have to know the common products or the common numbers and how they break up 1000, 5s and 10s. And then just you have to put values and get the answer. I think 90 seconds should be good enough to do this question and should be attempted in the exam. What is the highest possible value of n for which 3 raised to power 1024 minus n is divisible by 2 raised to power n? 3 raised to power 1024 minus n can be written as 3 raised to power 512 square. 1024 is 512 into 2 minus 1 raised to power 2, 1 square. So this becomes a square minus b square. So this will be a plus b into a minus b. Sorry, a minus b. The second term again, 512 can be written as 256 square minus 1 square. So this becomes 3 raised to power 512 plus 1 into 3 raised to power 256 plus 1 into 3 raised to power 256 minus 1. Further, this becomes, the plus terms remain as it is. 256 becomes 128 square. So 3 raised to power 128 square minus 1 square. This will become 3 raised to power 128 plus 1 into 3 raised to power 128 minus 1. This term can again be broken. Every time we have a minus between the two terms and even powers, we will break it down into x square, a square and b square. So this becomes 128 plus 1 is same. 128 can be written as 64 square. So 364 square minus 1 square, this becomes 3 raised to power 64 plus 1 and 3 raised to power 64 minus 1. So I'm just doing those steps now back to back here. 3 raised to power 64 here becomes 3 raised to power 32 square minus 1 square. So from there we get 3 raised to power 32 plus 1 into 3 raised to power 32 minus 1. 3 raised to power 32 minus 1 will be 3 raised to power 16 plus 1 into 3 raised to power 16 minus 1. 3 raised to power 16 minus 1 becomes 3 raised to power 8 plus 1 into 3 raised to power 8 minus 1, which becomes 3 raised to power 4 plus 1 into 3 raised to power 4 minus 1, which becomes 3 square plus 1 into 3 square minus 1, which is 8. As we can see, these are powers of 2. 2, 4, 8, 16, 32, 64, 120, 250, 512. All of them, 1 is added. Now, if we have to look at the power of 2 that divides this entire thing, 3 raised to power 512 plus 1. This obviously is an even number, so there will definitely be 1, 2 here. If we divide this by 4, 3 raised to power 512 plus 1 divided by 4 will be 4 minus 1 raised to power 512 plus 1. From here, we will get the remainder as 1 raised to power 512, which is 1, minus 1 raised to power 512, which is 1, plus from here we will get remainder 1. So the remainder will be 2. So for each of these terms, they will be divisible by 2 but not by 4 because of the same reason. So this will get divided by 2 once. This will also get divided by 2 once, same here, same here, same here, same here, same here, and this is nothing but 2 cube. So how many 2's are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And therefore, this number will be divisible by 2 raised to power 12. The value of n becomes 12. I'll call this question a moderate to difficult level question unless you're able to break the terms and then count or understand the division of the term by 2. This might be a little difficult. Even if we are able to figure that out, it will easily take 2.5, 3 minutes to solve. So moderate to difficult level of question. A is equal to 28 raised to power 12, B is 18 raised to power 8, C is 21 raised to power 6. How many natural numbers are there by which at least one among ABC is divisible? Now, if you look at A, it is 28 raised to power 12, which becomes 4. 2 square into 7 raised to power 12, and therefore 2 raised to power 24 into 7 raised to power 12. B, 18 raised to power 8, which is 2 into 9, or 2 into 3 square raised to power 8, which becomes 2 raised to power 8 into 3 raised to power 16. C, 21 raised to power 6, which is nothing but 7 into 3 raised to power 6. So 7 raised to power 6 into 3 raised to power 6. Now, if we look at numbers that divide A alone, or that divide A will be the factors of A. So they will be 24 plus 1, 25 into 12 plus 1, 13. Direct formula for number of factors. So 250 plus 75, 325. 325. Number of factors that divide B will be 8 plus 1, 9 into 16 plus 1, 17. So 3, 1, 9, 63, 153. For C, it will be 6 plus 1, 7 into 7, that is 49. Now, is there any factor which divides ABC, all of them? Clearly, there is nothing common between ABC, so there is no factor which divides ABC. What I'm saying is factor of ABC will be only 1. What are the factors common for A and B? A and B common is the power of 2. From 2 raised to power 0 to 2 raised to power 8, everything will be common. So 2 raised to power 0 to 2 raised to power 8, which is 9 factors. Factors common to A and C. A and C has 2 and 7. C has 7 and 3. A has 2 and 7. The powers of 7 will be common and the lower number. So from 7 raised to power 0 to 7 raised to power 6. These are 7 common factors. Factors of B and C. B and C have 3 common. The lower power is 6. So all factors which are 3 raised to power 0 to 3 raised to power 6 are common against 7 common factors. Now what I'm saying is we are looking at numbers which divide at least one of ABC. So 325 numbers divide A. 153 numbers divide B, 49 numbers divide C. Out of these 9 numbers have been counted in both A and B, so subtract them. These 7 have been counted in both A and C, so subtract them. These 7 have been counted in B and C, so subtract them. Now this one was counted in all three and has been reduced from all three. So add it back again. This will give us the answer. So if we do add, this becomes 40 minus 14. 24 plus 1, 25. 40 minus 14 is 26. 26 plus 1 is 27. 27 plus 153 becomes 27 plus this becomes 352. 352 plus 153 becomes 505. The number of factors is option D, 505. Again, this question has concepts of set theory, factor theory, and divisibility. So basically, I think moderate to difficult level of question. And unless you're able to spot it, it might take up even up to 3.5 minutes. But once you spot the concept of set theory, should happen in about 2.5 minutes. If C is a positive integer, how many 3-digit numbers ABC are there such that ABC and CB are divisible by 4? If ABC has to be divisible by 4, C is a positive integer, cannot be 0, and obviously A will not be 0, otherwise ABC will not be a 3-digit number. So BC can be 0, 4, 0, 8, 12, 16, 20 will not happen, 24, 28, 32, 36, 40 will not happen because C is not 0, 44, 48, 52, 56, 60 will not happen, 64, 68, 72, 76, 80 will not happen, 84, 88, 92 and 96. These are the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20. 20 possibilities for BC. For every value of B, there are 2 possibilities of C. Now, we look at the number CBA and we want that to be divisible by 4 as well. So, in the first case, C will be 4, B will be A. How many values can A take? With B0, the last 2 digits to be divisible by 4, A can take either 4 or 8. 2 values. Similarly, in the second case, 8, 0, for 0 something to be divisible by A, divisible by 4, A can take values of 4 and 8. So for 0, these two cases will repeat for A as well. Similarly, when we look at 2, 1, 2, 2, 1 and then A could be either 2 or 6, so that 12 or 16 is divisible by A. So with 1, A will also take these two values. And therefore, if we repeat this pattern, we realize for every case, there are 2 cases for A and B. And those are the numbers that C is taking when B is 0. And therefore, the total number of cases possible will be, for BC there were 20 cases, and for each case of BC there are 2 cases for it, therefore 40 possibilities are there. In terms of level of difficulty, I'd say moderate level of difficulty. Spotting the pattern takes a bit of time. Once you spot that pattern, it should not be difficult to solve the question. But again, 2.5 minutes definitely to solve the question. And if we're not able to spot the pattern in about 1.5 minutes, this question then should be left in the exam. Is the sum of squares of the first and natural numbers where n is less than 100? For how many values of n will A be divisible by 5? Now A will be given by the formula n into n plus 1 into 2n plus 1 by 6. Sum of squares of first and natural numbers. For A to be divisible by 5, one of these terms has to be divisible by 5. Now, in how many cases can n be divisible by 5? If n is a number that n is a multiple of 5 less than 100, 19 such multiples are possible, from including 5, 10, 15, 20 up to 95. So 19 cases here. The second possibility is n plus 1 is a multiple of 5. If n plus 1 is a multiple of 5, n plus 1 should end in 0 or 5. This should end in 0 or 5, which means n should end in either 9 or 4. So that we add a 1 to it, becomes 0 or 5. So n plus 1 could be a number which ends in 4 and 9. So 4, 9, 14, 19, 24, 29 and so on till 94, 99. So in amongst every 10 numbers, there will be 2 such numbers. So there will be 20 such possibilities: 0, 4, 0, 9, 1, 4, 1, 9, 2, 4, 2, 9. So from 0 to 9, 10 cases, two numbers in each case, so 20 cases here. The third possibility is 2n plus 1 is a multiple of 5. 2n plus 1 will be odd because 2n is even, 1 is odd. So 2n plus 1 cannot end in 0, but 2n plus 1 can end in 5. If 2n plus 1 ends in 5, 2n has to end in 4, and therefore n can end in either 2 or 7. So numbers ending in 2, 7, and therefore 12, 17, 22, 27, and so on till 90 to 97 will also give us the same values, or will give us a multiple of 5. So here again there will be 20 cases. So a total of 59 possibilities are there. I would say this is a relatively easy question, might take some time, but there are three different terms and we just have to get a 5 or a 0 for that term and count the numbers. This is probably a question that could be looked at in the exam as well. In this question, if S1 is equal to S1 is a set of 1, 2, 3, 4 numbers till 23, S2 is a set of numbers from 207 to 691. In how many elements of the set S2 are divisible by at least 4 distinct prime numbers? Divisible by at least 4 distinct prime numbers. So they should be at least the product of 4 distinct prime numbers from S1. So what I'm doing is I'm making cases here outrightly. I'll take the smallest possible 4 prime numbers, which are 2, 3, 5, and 7. 2, 3, 5, and 7. This product becomes 5 to the 10, 7, 20, 210. This is in the range, so this is one number. From 210, we can multiply this by 2 to get 420. Multiply this by 3 to get 630. All these three numbers will be in the range, and they will be divisible by at least 4 distinct prime numbers, 2, 3, 5, 7. Then we can make a case for 2, 3, 5, and 11, the next 4 prime numbers, or the next prime number. This will be 10 and 330. 330 can be multiplied by another 2 to get 660, which is still in the range. And both these numbers will be divisible by at least 4 distinct prime numbers. Similarly, we keep counting for 2, 3, 5. The next prime number is 13. This will be 3 into 13, 390. 390 into 2, 780 crosses the limit. So only one number, 2, 3, 5, 17. 17 into 3 is 51, into 10 is 510. 1, 1. 2, 3, 5, 19. 19 into 3, 57, into 10, 570. Cannot be doubled. 2, 3, 5, 23 is the next prime number. So 3 into 6, 23, 69, into 10 is 690, still in the range. And we come to the end of the range of S1. Now what we do is we eliminate 5 and look for the next prime number. So we take the smallest 2 into 3, eliminate 5, work with 7. 2, 3, 7, 11. This will be 77 into 6. 420 into 46. 6 and 42, 4, 42, 462. This is also in the range. 2, 3, 7, 13. 7 is 91. 91 into 6 will be 546. This is also in the range. 2, 3, 7, 17. 17 into 7 will be 17 into 7. 70, so 49. 119 into 6. This will cross the range of 690, so not a case. We drop 7, or rather we drop 3 and pick up cases with 2, 5, 7, and 11. This in itself crosses 690, this 770 is not a possibility. Beyond this, no other case will be possible. So 3, 2, 5, 6, 7, 8, 9, 10, 11. 11 cases are possible where we can multiply at least 4 distinct prime numbers and one common prime number from there and get a number in the set S2. Again, since we are just counting, I'd say a moderate level of difficulty question. The only thing is this might take some time. So I'm saying attempt time could be up to 3 minutes. How many numbers are there between 0 and 500? Which one divided by 3, 4, 6, 8? Leave remainders 1, 2, 4, 6. Divisors are 3, 4, 6, 8. Remainders are 1, 2, 4, 6. The difference in all the cases is 2. And therefore, The smallest number satisfying this condition will be LCM of 3468. We don't even have to look at 6 and 8, 3 and 4 would suffice. Or vice versa. Look at 6 and 8, 3 and 4 by default will happen. 3468 LCM will be 24. 8 is 8. 6 is 2 into 3. 2 is here. So 3, 4 and 3 are already present in 8 and 6. So 24 minus 2, that is 22, becomes the smallest such number. But we're looking at how many numbers are there between 100 and 500. So the smallest number will be 22. The next number will be 22 plus 24 into 1, adding the LCM. 22 plus 24 into 2 and so on. The last number that we can go to is 24 into 20 is 480 plus 22 will cross the range. So 22 plus 24 into 19 will be the last number in the range 0 to 500. This will be 480 minus 24 plus 22. So 2 short of 480, which is 478. So from 22 to 478, or we are counting from 0 to 19, which will be a total of 20 numbers, and that becomes the answer. That's a moderately easy sort of a question. 2 minutes good enough to answer the question. Definitely something that should be done in the exam. The digits of a 3-digit number A are written in the reverse order to form another 3-digit number B. B is greater than A. So if A is, say, XYZ, B is the reverse ZYX. B minus is perfectly divisible by 7. So B minus A will have a value of 100Z plus 10Y plus X, standard form of a 3-digit number in decimal system, minus 100X plus 10Y plus Z. This becomes 100Z plus 10Y plus X minus 100X minus 10Y minus Z. 100Z minus Z is 99Z. 10Y minus 10Y is 0. X minus 100X is 99X. So we get 99 into Z minus X. Also, B is greater than A, therefore Z has to be greater than X for sure. This B minus A is perfectly divisible by 7. 99 is not divisible by 7, therefore Z minus X has to be divisible by 7. And the highest value that Z minus X can take is 7, it cannot be 14. So for that, the possibilities are Z becomes 8, X becomes 1, Z becomes 9, X becomes 2. Z cannot be more than 9 because it is a single digit number, and Z cannot be less than 8 because if Z is 7, X will be 0. 0 will not give us a 3-digit number for X. So these are two cases. Which of the following is necessarily true? So if we look at the value of A will start from 1 dash 8, and the highest value that A will have will be when A is 2 and dash X, Z is 9. X is 2, Z is 9. For the smallest value, we will take the smallest possible value of Y, which can be 0. For the largest value of A, we will take the largest value that Y can take, which is 9. So the smallest value for A is 108. The largest is 299. Not all the numbers in between, only where the first number is 1, the last number is 8, or the first number is 2 and the last number is 9. Y in between can be anything, 118, 128, and so on. And therefore, the smallest value of A is 108, largest is 299. We look for a range where both these numbers are included. 299 is not included here, so not an answer. 108 is not included here, 108 is not included here. If we look at this range, A is greater than 106, 108 is included. A is less than 305, so 299 is included. Hence, option B becomes the answer. I would say an easy to moderate sort of question. 2 minutes good enough to get the question done. A natural number n when divided by a certain divisor leaves the remainder 19. N when divided by a certain n when divided by a divisor leaves the remainder 19. If twice the number 2n is divided by the same divisor, in that case the remainder should be double of 19, that is 38. But what happens is the remainder is 7. And therefore we can say that the remainder should be 38, but when we divide 38 by the divisor d, we are getting a remainder 7. Which of the following is true? This simply means that d should divide 38 minus 7, which is 31. So when n divides d, the remainder is 19. 2n divided by d should give the remainder as double. But that does not happen since the remainder crosses d. And therefore, 38 again divided by d gives us a remainder of 7. So the value of d is 31. Which of the following is true? N lies between 10 and 20? No. N can only be 50. N can be any value such that it is of the form 31x plus 19. Anything will do. The divisor is 19. Yes, it is. Both B and C. No, only B is correct. Option C becomes the answer. Again, easy question. Should be able to do this in about minute and a half. Let S be a set of positive integers such that every element of n of S satisfies the condition. The number is between 1000 and 12,000, not between, but from 1000 to 1200. Every digit of n is odd. Okay, so if we look at n, obviously the first digit will be 100, and obviously the first two digits of n could be either 10, 11, or 12. Every digit of n is odd, therefore the only possibility is that the second digit is also 1. So all the numbers that we are looking at for n are in the range of 1100s. How many elements of S are divisible by 3? How many elements of S are divisible by 3? Okay. So for 3, the sum could be 3, 6. In this case, the maximum sum possible is 9 plus 9, 18 plus 2, 20. So 3, 6, 9, 12, 15, 18. We'll try to get these sums. Out of this, 2 is already there. So if you look at the two digits A and B left, here A plus B should be 3 minus 2 because 1 and 1 are already there. So this will be also one more thing. A and B are odd numbers. Since A and B are odd numbers, odd plus odd plus odd plus odd will be even. So the sum cannot be 3, 9 or 15. 3 cases possible, 6, 12, 18. In this case, A plus B has to be equal to 6 minus 2, 4. This can only happen with 1 and 3. For 12, A plus B has to be equal to 10. This can only happen for odd numbers with 1, 9, 2, 8 will not work, 3, 7, 5, 5. 18, A plus B has to be equal to 16, which can happen only with 9 and 7. Now, here we will have two cases, A1, B3 or B3, A3, B1. For this, we will have two cases, 1, 9, 9, 1, 3, 7, 7, 3, 5, 5 will have only one case. So, two cases for the first one, 2 here, so 4, plus one case here, A and B both being 5, plus two cases here. So, a total of 9 cases are possible for element n in S. Hence A, the answer. Again, that's a moderate question. There are 2-3 constraints that have to be checked. So maybe time consuming, but conceptually not very difficult question. So if you look at the overall test, as I said initially, moderate level of difficulty because there are some questions which are time consuming and maybe even difficult. So that increases the time, but 6 questions net can easily be found. For me, my 6 questions in this test would be, 1, 4, 5, 7, 8, 9. Which are these ones? This is something I will definitely do. Just looking at multiples. This could have been left in the examination, especially if not done similar questions earlier. This again was a challenging question. This was a simpler question, just making and counting cases. Even if it takes time, we'll get the answer. This I think was also easy. We had the formula. We just had to look at multiples of 5. This I think was a question where you can easily miss cases. So these questions always are a little tricky. Definitely would have done this straightforward question. Would have done this as well because simple constraints, simple ranges. So not very difficult to do in the exam. This I thought was also easy. Basic application of remainders. Here you can look at it. I mean, since I'm looking at 6 questions, a mistake here and there. So ideally, this would be a question that you would do, but I'm not counting this in my 10. Overall, 1, 4, 5, 7, 8, 9 is something that will give you 6 net attempt, correct, and a percentile of 95 odd.